I like it that way. It's safer, but at the same time very expensive. So this is the typical layout for a hand layup. This is from a book by Agarwal. Agarwal's book is very good book. If you want to learn something about fabrication stuff like that, his book has lots of details. So you place your mesh or fiber here, you pour your resin and then you squeeze it and you just make sure there is no excess resin. That's all. And this is your mold. That's the mold. And at the contact surface here, you normally add some releasing agent, which is just like form oil. Just spray that and then that's it. And here you can add your gel coat, or if you want to have a logo here, you can put that logo here, do whatever. Okay. And this surface of the composite will be it will have good finish, but the top surface will not have very good finish. Spray up method is partially automated. So you have, it's like shotcreting. You know shotcreting, right? You must have seen some pictures, or at least you would have seen some videos of how shotcreting is done. So this is composite type of shotcreting. That's what it is. So you have chalk fiber, you just spray it, and operator skills are very important in this case, just like in your shotcrete. And then physical properties are somewhat inferior and non-uniform, but you know, there is a saying called horses for the courses, right? Do you understand what it means? If you have, let's say, racing course in Bangalore, you need one type of horse. If you have a race course in, let's say, Delhi, the temperature and everything is different, so you have a different type of horse. So you bet on a different type of horse in Delhi and compared to what you would bet on a horse in Bangalore. So horses for courses, that's what they call it. So these are all just like that. It is depending on your application needs, you can use different processes. So it's just like shotcrete. You see that? This is the mold, and you put your releasing agent and then just spray it. So there's a continuous feed of fiber, continuous feed of resin, and anything that you want to add, accelerators, whatever you want to add, additives, they're all pumped, and at this point it's chopped, the fiber is chopped into small pieces, and then it mixes at the head where they're shooting, and then that's your spray up method. Okay, very simple, right? Filament winding is very, very common. That's what we have, all researchers have tried using filament winding. Filament winding is very simple method to make surfaces of revolution. That's very important. You cannot make filament winding or use filament winding for flat surfaces. That's not possible. So anything like tubes, cylinders, large tanks, all these are made with filament winding. So in this method, what they do is, let's say this is the part you are trying to fabricate. The fiber is wound around the mandrel, some kind of cylinder, metal cylinder, and then while it's winding, you also spray the resin. When you are doing that, you wet the fiber and then wind the wet fiber around the mandrel. It can be automated, and it says low labor, but if you are doing anything in your lab, it's not going to be low labor. It will be very labor intensive. I'll show you some pictures. These days they have machines that can program the rate of rotation and how far the fiber should go, which way it should go. All those things can be modulated with this. Okay. There are a lot of advantages. High production rates, high strength product, and size. You can vary the size for the same machine you can make a small tube or you can make a large tube. So you can control strength in different directions. That I will show you. I'll show you what I mean with a figure. But there are also many disadvantages. So if you have a reverse curvature, what I mean by that is can you turn on the light, please? So let's say you want to make a part something like this, just like a bean or something like that. So you are trying to do this, right? You're winding your fiber around this. So this part cannot be filament wound. It's not possible. If you have a reversal of curvature, you cannot just do filament winding. Okay, that's a problem, but you can have a different, you can use a different process for that. Okay, and winding at low angles is difficult, but if this is the longitudinal axis and you are winding at a very low angle, like in this direction, it can be very hard to do that. Complex shapes, not possible. The external surface will not be smooth, so it will be unfinished external surface. And this is what it looks like. You have different fibers arranged, and this is the bath, resin bath. This resin bath will move, you can program it to move along the length of the item or the part. So with proper programming, you can wind it to some extent at an angle like this, or you can wind it strictly perpendicular or in the circumferential direction. So if the angle is too steep, it will slip. It won't work. But if it is not too bad, not too steep, it will work. So different types of filament winding pattern. You have circumferential or hoop directional, helical, and longitudinal. This is more tricky, but it can be done. So in our lab, this is what we did. This was done long time back. These days I am not doing this anymore because the way it works in our university is if you have funding in a particular area, you do work in that area. Now this is so much studied that there is no funding in FRP related research. So we don't do anything much about filament winding. So anyway, this was done in the lab. One of my colleagues, Srinivas Iyer, he did this. He's a professor. He and his students and my students, we all did this. So you see, this is the mandrel, right? That's the mandrel. You can have a small mandrel for small tube or a very large mandrel for very large tube like this. So the machine is the same. The same machine is being used. You can program it to rotate at a certain speed, and you can, this is the bath. It's where it gets wetted and then you wind it. So preparation is a very, very difficult task. You see all these students, so many of them, you have to buy them some lunch or something to come and help us. So, you know, you need a lot of students to work on this kind of projects. And the fiber is stacked like this, and then you have to work with some hand squeezing. So you squeeze it out, add some pigment if you want, stuff like that by hand, and the final product looks something like this. So the biggest problem is to remove the part from the mandrel. It's very, very hard. You can see how difficult it is. This is the mandrel, and then that's the part. So removing the part from the mandrel is not likely to be fun. Okay, now we'll move on to the next method, which is pultrusion method. This is the most common method these days to make bars and also products like this. So you make reinforcing bars using pultrusion. This is not necessarily bars. This is flat plates, like flats. That's what they're showing here. It's a pultruded section. with some kind of shape profile. So this kind of sections can be made by pultrusion. So just like you do in steel plant, what you do is you melt the steel. While it is setting, you just squeeze it and squeeze it multiple passes if required. So a bar of, let's say, 1 meter by 300 millimeter and maybe several meters long, that bar is heated and it is squeezed and squeezed between rollers to get your shapes. That's in steel construction or steel fabrication, manufacturing. So this kind of shapes can be made by squeezing between rollers. This is somewhat similar to that, but there is no pressure involved here. They don't really put too much pressure. I don't know if do you apply pressure except for squeezing? Yeah, you don't really put external pressure on that, right? No, I don't think so. Just for squeezing out excess resin, you can put slight pressure, but other than that, you wet your fiber here, pass it through the profiler, and then you get the part here. That whole process doesn't take very long, and sometimes you can cure it in the process line, so it is very simple to do. So thermoplastic matrices I will not go over because those are mostly mechanical engineering related. So the next thing is that's the end of my presentation on manufacturing. How are we all doing? Are you all tired of listening to me? No, that you will say, because you won't say it. Yes, I'm tired. Of course you won't say that. No, but let's be, yeah, you want a break?